we want to continue talking about Pascal's law. Last time we looked at Pascal's law in terms of this cube here, and we used Newton's law, Newton's first law: body at rest tends to remain at rest unless acted upon by some external force. And we balanced out those forces, and we came up with this nice little equation down here. And it's the pressure at a given reference point in a fluid. So now we're going to talk about this, and I'm just going to read Pascal's law to you. Pressure applied to an enclosed fluid is transmitted undiminished to every portion of the fluid and the walls of the containing vessel. The pressure depends only on depth. The shape of the container does not matter. So let's say we apply a force here. Say we apply a force right here. All right. And let's call this a piston. All right. And this piston has an area. Let's call this area 1. Now, when we apply this force, let's call this F1. This force is going to have a force that's going to act right back on it. And that force is going to be defined as the pressure in the fluid times the area. And you know what? I almost would rather it be different, but we're just going to flow with this. Just know that the force that's going to act directly back on F1 is going to be pressure times area sub 1. So the pressure in the fluid is going to be the same all the way through according to Pascal's law. So in the same way, this car is going to have a weight. It's going to exert a force as well. Okay, and as a result, we're going to have a pressure that's going to act back up on this. And this pressure is going to be the area of this piston here. We can call it another piston, times the pressure in the fluid. Okay, so let's just go ahead and write, well, I could say it's going to be equal here, and then this one is going to be equal to the pressure in this fluid. So here's what Pascal's law is really getting at. It's saying that the pressure in the fluid is going to be the same everywhere. So that means that if P is equal to F1 over A1, and if P is equal to F2 over A2, then P is equal to, and the pressure is just going to equal to F1 over A1, F2 over A2. And I should just say it's then F1 over A1 equals to F2 over A2. That's really what we're trying to get at. And so now we can kind of calculate based on the areas of these plates the kind of force that we would need. And so I can easily say, well, F sub 2 is just going to equal to the area on the second plate divided by the area on the first plate times the force of the first plate. So you can see right there that we can have a much smaller force on the first plate if the area is large. If the area is 10 times larger, that means that we can apply 10 times the force by using this kind of system, and we do when we want to use hydraulic jacks. Okay, pretty cool, huh? There is an offset, and that offset would just be that the left-hand side, or the smaller portion of fluid, would have to travel a greater distance. But so what? We can still cause this thing to rise. Cause this car to rise, to be more specific.